Hello everyone, I'm Dr. Godan Raman. In this section we are going to discuss with type 3 problem of one-dimensional heat equation with the temperature at both ends are non-zero and steady state condition. See the problem. The ends A and B of rod 30 cm long have their temperature kept at 20 degrees Celsius and 80 degrees Celsius respectively until steady state condition prevail. The temperature at the end B is suddenly reduced to 60 degrees Celsius and of the end A is raised to 40 degrees Celsius and maintained. So find u of x comma t. So first thing, steady state condition. Steady state condition. Steady state condition is nothing but the time. It's when your increases the temperature no changes. In the temperature no changes, some level it's constant maintain. Whenever you are increasing your time but the temperature no changes, so constant level. So this is the steady state condition. Now the steady state condition is nothing but dou u by dou t 0. Now what is a one-dimensional heat equation? Why I am considering one-dimensional heat equation? Because the problem rod, when is mentioned rod, I am just using heat, temperature. So one-dimensional heat equation is nothing but dou u by dou t equal to dou u by dou t equal to a square dou square u by dou x square. In steady state condition, dou u by dou t 0. So substitute 0 equal to a square dou square u by dou x square. Dou square u by dou x square. From this, dou square u by dou x square equal to 0. Now this is a partial derivative. Here u is a function of x. Therefore x is alone can be rewritten as the ordinary differential equation is nothing but, so since u is a function of x alone, this can be written as d square u by dx square 0. Now partial derivative, this is a partial derivative, this is a ordinary differential equation. When I am solving this equation, integrating, correct? Integrating, then it's coming with du by dx equal to a constant. Again integrating, u equal to ax plus b, ax plus b. So now this is nothing but u of x equal to ax plus b. This is a solution for this partial derivative equation. Now see the problem. So what is the problem? So we consider rod. Okay, in this rod 20 degrees Celsius, 80 degrees Celsius for ends. Therefore until the steady state condition. Now this is a rod. I'm going to consider rod. So this is a rod I'm consider. Now one end A, another end B. One end A, another end B. Now the length is nothing but 30 centimeter. So x0 to 30 centimeter. Now u is nothing but the temperature. So 20 degrees Celsius. Then another end 80 degrees Celsius. 20 degrees Celsius, 80 degrees Celsius. Now this is until steady state condition. Therefore the solution in steady state condition is nothing but u of x equal to ax plus b. So u of x equal to ax plus b. Now I consider this is a number 1 equation. And what is the boundary condition? Here A, B is nothing but we are going to apply with condition end A and end B. So boundary condition, first x 0, this is a 1, so u of 0 equal to 20 when x equal to 0. And then second one, u of the length other end 30 is 80, x equal to 30. Now using the condition, first condition, using condition 1 in equation 1. Therefore u of, put x 0, u of 0 equal to a 0 plus b. Now this term 20 equal to b. This is the second equation. Now substitute second equation into the previous equation 1. Therefore u of x equal to ax plus 20. This is the condition third equation. And then using condition 2, using condition 2 in equation number 3. Therefore the second condition, x equal to 30. Therefore u of 30 equal to a into 30 plus 20. So u of 30 value is nothing but 80 degrees Celsius. So 80, 30a plus 20. From this equation, when I change this 20 to the left hand side, 80 minus 20, 30a. So this is a 60. A equal to 60 by 30, a equal to 2. Now I consider this the fourth equation. Substitute the fourth equation into the previous equation. Substitute fourth equation into third. Therefore u of x equal to 2x plus 20. 2x plus 20. So this is the fifth equation. This equation I time t 0. Now what is the next one? So next one, in the next state with the condition is given after the steady state. So after the steady state, now this A end, B end, x length 30 centimeter length, so x 0 to 30. Now what is the value of yearly value until the steady state condition? U 20 degree Celsius and this U 80 degree Celsius. So suddenly this 20, okay, so the A end, B end, A end rise to 40, then B end reduce to 60. Therefore this is a reduce, this is a increase. Therefore now when this process will be start, the previous steady state condition, when that time increases, now it will be reduced and increase, then time is activated. Therefore in the situation, so what is the time started? In the situation we consider the condition heat flow. So heat one dimensional, heat equation is nothing but dou u by dou t and then a square dou square u by dou x square and the solution condition. So what is the solution in this equation? U of x comma t, a cos lambda x plus b sin lambda x e power alpha square, or here I used a, so a square lambda square t. And the condition, this is a boundary condition. What is the boundary condition? The first boundary condition, u of x 0 comma t, the two end initially 0, therefore 0, the boundary condition x 0. And then second one, u of 30 comma t 0, so x equal to 30. And the third condition, u of x comma 0, because the x alone, when up to steady state, the function we are going to apply with that, so 2x plus 20 when t equal to 0, this is equation 5. So now the changes, what is the changes? Here generally if u 0 comma t 0, 30 comma t 0, then as usual we are using equation 1, condition 1 in equation 1, find the value a0, then second xl lambda value, then using half range sine series we are solving weighting solution. But the problem is here u of 0 comma t the end not 0. What is the problem? Here 40, because of it's a B. So what is the problem here? 40 and 60. It's reduced, A end erased, B end reduced. So in this situation, when I substituted x0 for this equation, it's difficult to calculate the constant value. Then what we should try here? We split the equation because of the reason first to second condition non-zero. Hence we cannot solve the heat flow equation. Then how to solve the procedure? We split this first to second condition. So here the first, second conditions are non-zero. Hence we cannot solve the heat flow equation. Okay, then what should do here? We split the equation. Split the equation. So we split the solution into two parts. What's the two parts? U of x comma t equal to u t of x comma t plus u s of x. What is this? U t of x comma t is nothing but unsteady state. This is a unsteady state condition, and this is a steady state condition. Steady state and steady state condition during the steady state condition. Therefore to find us of x, first to find us of x, how to find this? The steady state condition, we know that at us of x we consider cx plus d. So now to find the value c and d in the condition when is increase and when is decreased, right? So second condition after rising and reducing. Therefore the boundary condition is nothing but first one, us of 0 equal to 40, so x is 0. Second boundary condition, us of 30, its length 60. Now this condition sixth, because already we used fifth condition, now consider sixth one. Therefore using first condition in sixth equation, using 1 in sixth, x 0. So how you return this boundary condition? Because of the rod. So when after reduce and then increased. Now x 0, to substitute the equation 6, us of 0, c into 0 plus d. Now us of 0 40, d value 40. Now I consider this is the seventh one. Now substitute seventh equation in sixth. Therefore us of x equal to cx plus 40. Now you consider this is the eighth equation. Now using condition 2 in eighth equation, put x equal to 30. So us of 30 equal to 30c plus 40. This us of 30 value is nothing but 60. Then 40. So when this 40 coming the left hand side, 30c equal to 20, c equal to 3 by 2. Now this is a ninth. Substitute ninth equation in the previous eighth. Therefore us of x 3 by 2x plus 40. This is a steady state condition when the temperature changed. This t equal to 0. Therefore next to find ut of x comma t. Ut of x comma t. So now how to find out this? From the step, the previous one, ut of x comma t. So u of x comma t equal to ut of x comma t plus us of x. Now this term I will take it left hand side. Therefore ut of x comma t equal to, sorry, this term we'll take it left. Which one? This term, the steady state. So ut of x comma t equal to u of x comma t minus us of x. Now we can solve ut of x comma t if we get the condition. What condition? We have x 0, x 30, t 0. To apply this condition, therefore first condition, ut of 0 comma t. So first put x equal to 0, u of 0 comma t minus us of 0. Now u of 0 comma t is nothing but the value 40 minus 40, then 0. This is x equal to 0. Then second condition, put x equal to 30. X equal to 30. Therefore second one, ut of 30 comma t. So u of 30 comma t, us of 30. So u of 30 comma t is nothing but 60 minus 60, 0, x equal to 30. Then t equal to 0. Third condition, ut of x comma 0 is nothing but u of x comma 0, then us of x, us of x. Now you substitute the u of x comma 0 value is nothing but 2x plus 20 minus us of x 2 by 3x plus 40. Now simplify this. 2x 20, 2 by 3x minus 40. When I simplify this, 6 minus 2 4, so 4x by 3 minus 20 when t 0. So this is our third condition. Third condition. Now what is the solution? Let us assume that the solution, suitable solution is nothing but ut of x comma t equal to a cos lambda x, b sin lambda x, then e power minus a square lambda square into t. Therefore this is considered equation 1. Now using condition 1 in equation 1. What is the condition 1? X 0. When I substitute x 0, ut of 0 comma t, then a cos 0, b sin 0, then e power minus a square lambda square t. The ut of 0 comma t, the first boundary condition value 0, then a square lambda square t. So this is a non-zero value, a 0. Now this is the second equation. Substitute second equation in the previous equation 1. Therefore ut of x comma t equal to a 0 b sin lambda x, then a square lambda square t. This is equation number 3. And then using condition 2 in third equation, so put x equal to L. So ut of L comma t b sin lambda L a square lambda square t. Here ut of L comma t value is nothing but 0. Then b sin lambda L a square lambda square t. For here b non-zero because of already a 0, again b 0, this solution trivial. Therefore these twos are non-zero. Sin lambda L, this 0 is nothing but sin n pi, sin lambda L, n pi equal to lambda L, then lambda equal to n pi by L. This is the fourth equation. Substitute fourth equation in the previous one, third. Therefore ut of x comma t b sin n pi x by L e power minus a square n square pi square t by L square. This is the equation number 5. Before that, this b constant to consider general constant. The general constant 1 to infinity bn sin n pi x by L e power minus a square n square pi square t by L square. Now this equation number 5. Now using third condition in 5. What is the third? T equal to 0. So ut of x comma 0 n from 1 to infinity bn sin n pi x by L e power 0. Now this ut of x comma 0 is nothing but 4 x by 3 minus 20 n from 1 to infinity bn sin n pi x by L. Now using half range sine series, using half range sine series is nothing but Bn equal to 2 by L 0 to L f of x sine n pi x by L dx. Now substitute 2 by L 0 to L 4x by 3 minus 20 into sine n pi x by L dx. Therefore, now I consider this is a u and this is a v. Differentiation. What is the differentiation? U equal to 4x by 3 minus 20 when I differentiate with respect to x 4 by 3. Again differentiate 0. This is the differentiation. Then integration v is nothing but sine n pi x by L, then v1 minus cos n pi x by L by n pi by L. Then v2 minus sine n pi x by L by n pi by L square. Now what is the formula? Bernoulli function uv dx equal to uv1 u dash v2 u double dash v3 and so on. Therefore, to substitute the value Bn equal to 2 by L u v1. So this is a u v1 u dash v2 4x by 3 minus 20 u v1 minus cos n pi x by L by n pi by L, then minus u dash 4 by 3, then v2 minus sine n pi x by L by n pi by L square 0 to L. Now where to substitute upper limit, lower limit? Where x? Here x, here x, here x. So in this place to substitute upper limit L. First upper limit L. Therefore 2 by L. When I substituted here L, 4 L by 3 minus 20. But the L value we should replace here, before that 30, correct? So we should replace L is nothing but 30. So all L value replace 30. From here L is the problem given 30. Just replace where used L 30. Here L, here L. So just to change 30. Or the problem is given L, then you just continue with L. This problem L 30 given, so I am going to change here L is 30. L is 30. So therefore 30, 30, this is a 30, lambda n pi by 30. Now this is a 30, 30 square, and here also 30, 30 square. So this is a 30, this is a 30. And then using half range series, this is a formula. So when I am apply this formula, then you change here this general formula, then change here 30. This is a 30, this is a 30, 30, 30, change. where L you change a 30. Suppose in last you want to change, also change it, so not wrong with that. So 2 by 30, 30, and this is a 30. This is a 30 square. Now substitute the upper limit and lower limit. So this is a 30, right? So when I changed here, where x, substitute 30. This is a 30, then 30, then minus cos. When I substitute 30, it's n pi by 30. Then when 30, it becomes 0, upper limit, minus lower limit. When I substituted 0, this 4 0, therefore minus 20, cos 0 1, minus 1 by n pi by 30, then this term 0. And now this is a term, cancel with this 3 3, so 10, 40 minus 20, 40 minus 20, minus 20 minus 1 power n pi by 30, then minus of minus plus minus 1 by n pi by 30. Now I'll take the common term, 30 by n pi into, I think it will be 20, into 20 also to take it out. Therefore then minus, I'm taking minus also common, therefore minus 1 power n plus 1. Now cancel this 2, minus 40 n pi minus 1 power n plus 1. This is a Bn. Now you consider this is the equation number 6. Now what is the previous equation? The previous equation 5. Therefore substitute 6 in 5. Ut of x comma t, n from 1 to infinity, minus 40 by n pi, minus 1 power n plus 1, then sin n pi x by 30 e power minus a square, then n square pi square t by 30 square. So this is the 7th equation. Actually this answer is nothing but ut of x comma t, but what value we are going to calculate? U of x comma t. So what is the u of x comma t? Ut of x comma t plus us of x. Therefore equation 7 and us of x value, this is the us of x, I'll consider 10. So 10 and 7 substitute where? In equation, this equation we consider. So this equation maybe I'll consider so we missed to take this equation, maybe we consider star whatever. Okay, and now substitute 7 and 10. Therefore u of x comma t equal to n from 1 to infinity minus 40 n pi 1 plus minus 1 power n sin n pi x by 30, then e power a square n square pi square t by 30 square, and then plus us of x value. So what is the us of x? It's nothing but 2x by 3 plus 40. So this is your final solution. Thank you.